Okay, so what we're going to do this morning is we're going to go through the specimen paper that you did as a mock way back in January. Okay, it was marked, but it's very, very important. One of the keys to success with this exam is that you understand the mark scheme, okay, or you understand the way the examiner thinks. Particularly for those longer questions where it involves 5 or 6 marks and it involves some kind of explanation. So what I'm going to do, I'm going to go through the whole paper, but some sections are very self-explanatory, so we'll just sort of whiz through those. Okay, and I'll just give you a few hints and tips. Do you want a piece of paper so you can write down some? You've got that. You're using your laptop, are you, Alex? Okay, so let's get on with it. Right, first question, fairly standard, fairly straightforward. Why do we use binary to represent data in computers? It's a 1-mark question. What's the answer? Alex?
State on or off, so because usually they're storing a number.
Yeah. So if you look at the mark scheme, this is one of the things that we go over a lot. It signifies the voltage, current, electricity being on or off. Okay. Converting things to denary, or the binary, sorry, so put it down to one in binary. I'm not going to go over that because you should be able to do that. Okay, if you're not able to do that at this stage, then you definitely need to come and get some help because binary conversion is on every single paper. Hex to denary. How do you feel about that?
Quite confident, I think.
Confident? Bad? Okay, so Finn, if you feel bad about it, you need to come and see me at some point and we go over hexadecimal. This is what I was talking about with the class the other day. Like, you've all got little skeletons in your closets. We need to sort of clean that out now. So you've got a couple of weeks, because I know you're on study leave on Monday, but you've got a couple of weeks where you can still come in and drop in and say, can you talk me through hex? Okay, you lads will have something that you're not very good at. The difference between success and failure here is going to be who sorts out their problems and who just leaves them. Okay, if you leave that problem, you're going to lose 2 marks on the exam because it's on every single one. Okay. But yeah, you need to be able to do it. Binary to hex, hex to binary, hex to denary. Right, just want to comment on this one. Very straightforward question, easy 3 marks if you've read it properly. Okay, which 3 of the following are common data types that most programming languages provide? Okay, so Boolean, that's a data type that's common. Integer, that's a data type that's common. And character, that's a data type that's common. Okay. We do see quite a few people getting 2 out of 3 on this question because I don't think they've read the common data types. I think they've just, what's in a programming language? Boolean, seen that. Integer, seen that. While, seen that. While is in there, but it's not a data type, is it? Okay. So again, reading the question properly is essential to your success. This is quite a common question. We've seen this on a couple of exams as well. So you've got a piece of kit like a smartphone and it asks you things about it, such as the classic input-output question. So it's a tick in a box, it's easy marks. Remember, if you aim for 1 mark per minute, you'll finish on time, no problem. Well, all you've got to do for these 4 marks is put 4 ticks in the right place. So you should be able to finish that question in like 30 seconds. But make sure you do it right. So vibration alert, is that an input, an output or both? It's an output. Yeah? Touch screen. Bit of both, because input, and you can also see it, so it's output. Microphone? Speaker? Output. Okay. I think it's the easiest question in the world, but not everyone gets 4 marks on it. You know, in that mock in January, your class, they did not all get 4 marks on it. I don't know why, but they don't. So make sure you're thinking things through. Like I say, just because you can do it in like 10 seconds, it is worth 4 marks. So technically you could spend 4 minutes on that and still be okay for time. and I'm not suggesting that you do spend 4 minutes on it, but do think it through. Don't just go ticking, because you know, one of the mistakes that people make is speak it as an input. You know, just rushing. Right, this is the kind of question that we really want to spend a bit of time on. Okay, these are the questions, particularly for you lads who are all aiming for sort of B+ grades. These are going to be the difference between getting it and not getting it. For a C, all you need to do is go through the paper and answer questions like that correctly. You know, and any marks you can pick up on these is a bonus, which is why many people who are sort of going for a C end up getting a B on the exam. Okay, but to go above a B, you need to start getting these right. And you need to start thinking about what you're saying properly. So give 3 developments in hardware that have made smartphones like the one above possible in the last 10 years.
Making the hardware smaller and more faster and more powerful and smaller.
Yeah. So there's a whole raft of things there, and I kind of know what you're talking about. But your verbal answer there is very typical of the kind of answer that I see written here. On the right kind of lines, but all a little bit confused.
Make it sound better, like more powerful and compact. Or were those separate points?
Well, the way I always explain this one is, you know, your smartphone is not more powerful than a supercomputer from 10 years ago.
A supercomputer took up a whole room.
That's right. Okay. So I actually like the first point that you made the best. The hardware has become more compact. Okay, and if you want, you can give examples of that. So, you know, the processor speed has gone up while also being made smaller, being miniaturized. Don't just say processor become more powerful, because that's not what's allowed the device to be made. It's the fact that the processor can now fit, a reasonably powerful processor can now fit into a phone. You know, same argument as with a Raspberry Pi. Okay, so I'll give you the smaller processing one. What else?
Touchscreen maybe? Because that's only...
Yeah, invention of the touchscreen, because before the touchscreen you would have needed a keyboard of some kind, and straight away that adds to the size of it. Yeah, so touchscreen technology has been an important development. I don't know if that would make my top 3. It's 3 marks, so I'm looking for 3 points.
Storage.
But I'd give you the mark for that.
Is battery one of them?
Sorry?
Battery.
Well, go on, talk to me about battery.
Well, the amount of power they can store has... The hardware's got better, basically.
How?
Batteries. Well, it's gotten the same as the processor. It's got more powerful and
it is the same argument as the processor.
yes.
But again, no disrespect to you, Finn. We're here to learn. You're doing a bad job of explaining it.
Yeah, I know.
Okay, it's all right. The big advancement in batteries is the lithium-ion technology. So we used to have lead-acid batteries. You know, these things are heavy. Lithium-ion, it weighs less, it's more compact, but it can still give you a reasonable charge. So remember, you've got to make 3 clear points. So you've got enough room there to explain what you're saying. Battery technology has improved so that we can have a smaller, lighter unit that still provides us with a reasonable amount of charge. Do you see what that sounds better than you kind of having little stabs at it? You know, you probably would have got to that explanation eventually, but when you're writing, don't take stabs at things. Okay? It's okay to do it verbally, but I'd be worried if you're writing, it's coming into my head, I'm going to write it down, because what you end up with is a load of disjointed sort of nonsense that's not very well explained, and you end up getting 1 or 2 out of 3. Okay, so you give me 3 things, anything else? You think?
The solid state drive.
Yeah.
Mm-hmm.
Why is the solid state drive better?
It's smaller, but it can hold more.
Again, exactly the same argument. Solid state drivers come along and replace magnetic disk. So it's for about the same storage, it's a lot smaller and a lot lighter again. Okay.
And it doesn't break.
Yeah, and it's more robust and it's quieter as well. You know, can you imagine if you were walking around with your phone and it was doing all that clicking and whirring, you know, in your pocket? People would think you're a right weirdo, wouldn't they? Let's just have a look at the mark scheme on that one so you can get a feel for what the examiner is thinking. So it says any simple answer that is a hardware development. So nothing to do with program or operating system or anything like that. It's got to be physical. So more power efficient processors, because that gives you longer battery life, the fact that your processor is more efficient. Smaller form memory or solid state memory, which is what Yang said. Affordable touchscreens, okay, which is what Alex said, and there are other things that you can have. But I always think it's useful. The examiner has chosen to write down 4. So for me, they'd be my top 4, because that's obviously what they want. Okay, if you read mark schemes that way, you've got this paper and you've got 3 other past papers from AQA. Start reading the mark schemes and thinking, right, what's their top 3 answers? Right, they're now my top 3 answers. They do change a little bit. I don't think that that is necessarily a great answer. I much prefer that one, I think. Alright? But that's the kind of process. That's the reason I'm giving you past papers. I'm not giving you the past papers to see what the questions are like. I'm giving you the past papers to see what the answers are like. Okay? What have you been there? Right. We did not do well on this question as a group, and we hardly ever do. 2 personal computers are advertised with different hardware specifications. PCA has a quad-core processor with a clock speed of 2 GHz. PCB has a single-core processor with a clock speed of 4.1 GHz. Which processor do you think is likely to run instructions more quickly? Okay, this is a 3 marker. Alright, I don't think anybody got any more than 2. So, go on Alex, you have some ideas, what do you think?
PCA. This has 4 cores.
Okay, has 4 cores.
Yeah.
So?
It's running, it has 4 lots of 2 GHz essentially.
Yeah.
So it's going to be running 4 of them, so 4 times 2 is obviously more than 4.1, and that's a single core. So it only has 1 core, which will only have 1 lot of 4.1 GHz.
Yeah.
So PCA will be running more quickly because it has more cores doing more things.
Okay, and you think that's a 3 mark explanation?
2 mark maybe?
2 marks, I agree, 2 marks.
You need to compare it.
Yeah, need a bit more comparison, I think. To be honest, this could easily be a 2 mark question, in which case your answer would be very good.
Yeah.
But they've made it a 3 marker, so we've got to try and get 3 clear points. Rather than sort of verbally gibber jabber on, I'm going to show you. This is what they were looking for, which isn't necessarily what I would have thought, but this is what they were looking for. If you're going for answer A, there are no marks for saying PCA or PCB. I think that confuses a few people, because I think people think, right, I know it's PCA, so that'll be 1 mark, and then 2 marks for justification. Actually, they've not done it that way, which is unusual. It is a strange question. It has 4 cores that will allow it to process 4 instructions in parallel at the same time. I would actually argue that your answer was better, in that you've actually quantified it. You know, you've said it's 2 GHz with 4 cores, so you've got the 4 cores bit, okay? And because you've effectively said it's 2 times 4, I would accept that you're saying parallel and at the same time, but hardly anybody mentioned the word process in their answers. And when something's underlined in the mark scheme, it has to be there. So it's an unusual mark scheme. Remember, this is a specimen paper, which means it's been through less editing, less refinement. I find it hard to believe that that would be the final mark scheme on a proper exam paper. I think there'd be another bit that says, oh, they've quantified it, and you might get 3 marks there. But if you get a question on core processors, please make sure that you mention the word process. Okay, they also like this word. Parallel, at the same time, simultaneously. You know, if you're going to be explaining multi-cores, we want to know that multiple cores are processing things simultaneously, which increases the effective output. Try and explain things properly. They did actually accept point processor B as well. Has 1 core compared to 4 in B, but this is only an advantage if the programs can be run in parallel. Yeah. The clock speed of B is over twice that of A, so every instructions can be processed faster. So I wouldn't, nobody put that, but technically it is true. You can only run multiple cores at once if the program allows you to. Which most programs probably would these days, which is why you make the assumption. Right, this was a poor question from us as well. Why is it important for both of these personal computers to have sufficient amount of RAM? Why do we need RAM? It's faster. Why is it faster? Why does it make life faster?
It's got less to search through.
Yeah, but we're going to need more.
RAM, so it's got less. If you try to bring up a certain program or a certain part of the program, then it's got less to look through. Well, if it's from the backing storage, it's got a lot more.
Okay.
It's like narrowing down the library.
Yeah. See what you're doing verbally, so it's fine. You're stabbing at it. It's faster. It's faster because there's not so much memory to search through. There's not so much memory to search through because we haven't got to go back in storage. So you are getting there, but it doesn't flow very nicely. Okay. So what's missing is you sort of mentally have that stab, and then think about how you're going to phrase it to weave all those points together.
Yeah.
Okay. And like I say, Alex, we're having a verbal chat here, so I'm expecting. But what I'm seeing on papers is I'm seeing that kind of writing.
Right.
I'm seeing it makes the computer faster. Because there's not so much memory to search through. And then because it's 2 marks, then leaving it.
Yeah.
But you haven't really got the essential point that by having the RAM there, it stops you from having to talk to the backing storage, which runs much slower. So again, worth having a look at their explanation. A large amount of RAM enables more instructions or programs to be loaded from secondary storage into RAM so they can be executed by the processor. Again, I don't think that's the best answer in the world, but it gives you an idea of the type of things that they're looking for. Faster. That means more instructions or programs going through the processor in a set period of time. Okay? The idea that secondary storage or back-in storage, you're getting it from there into the RAM. If the RAM is larger, you can get more instructions from that slow secondary storage. Okay? So I'll just point on those 2 questions because I know that we've covered them. I know that we've done enough work to be getting 5 out of 5. It's just the way that people are phrasing their answers and sort of approaching their answers that is causing us to get like 60% on some questions. So try and calm down a little bit on these written questions. Think about it. If it helps, I think you get a spare sheet of paper in the exam, don't you? Write your stabs, your points down on that piece of paper, then have a think about how you're going to write them down properly using as many technical words as you can, and then write it. That would be my advice, because we lose far too many marks on the written questions. But then again, everybody does it this time of year, so by the time you get into the exam, should be fixed. We've managed to do that other years. Right, name of a parameter.
Name or value.
Yeah. Because you've now done controlled assessment, you know, I would expect your programming skills to be better than they were before. Okay? So questions like this should suddenly have become easier. Same with the last question about pseudocode and writing down an algorithm. You've now written down pseudocode, you've written down algorithms. So these are things that you should be really good at, and you shouldn't have to revise too much. Just doing the questions and then checking that you're right against the answers should be enough. I'm not expecting you to change your whole approach on these. There should be, programming questions now should be pretty simple. So yeah, name, or you could have had value, yes? Because they're the ones in brackets separated by a comma. What's the data type of name?
Yeah, right, that's it. I knew it would be on the I just couldn't think of anything else.
It's what, sorry?
Array.
Oh.
Array, because it's got like brackets and then
Is an array a data type?
that's data structure.
That's a data structure, isn't it?
No.
So it is true? Very well.
The square bracket means the first letter in the string, or the second.
It does, doesn't it? So you've taken something in. It's not. It doesn't appear to be an array there, does it?
No.
There's no brackets. So as Leo says, the fact that there's now a bracket here suddenly makes me think that name is a string and you've just taken the first character out. Yeah? We don't act that way with numbers, do we? If we've got an array of numbers, we have to set the array up properly. So, yeah, I'm going to go with a string on that one. What's the data type of the return value? Boolean. Return true, return false. It's Boolean. 3 reasons why programmers use functions. I think this is important. Why do we use functions in programming? Because we've had to teach you something extra. You know, it's that extra bit more complicated. But why do we use it? There's got to be a reason. Alex?
Saves the programmer having to rewrite they're working out over and over again. It means they can just essentially have a shortcut to it.
Okay, so it improves code readability.
Yeah. And
Yeah, by not having to repeat sections of code.
saves the amount of space they have to write, like amount of lines.
Yeah, but the thing is, you're still in readability really. So improves readability of code by not having pieces of code repeated. That's point number 1. What else?
Improves robustness
Why?
because errors can easily be found. through-
Yeah. Improves robustness because errors can more easily be found. Yeah? Anything else? And if you fix the error in one place, you fixed it in all places. Yeah?
Efficiency. So because you can repeat it multiple times, you use up less lines in the program.
Yeah. So does that come under readability still?
Hopefully, yes.
Why else do we use functions? Are all the functions that you use your own?
Use functions save.
What's the advantage of that?
Well, inbuilt functions save the coder's time.
So it is efficiency in coding time because we can share different functions.
like random.
Like random. You wouldn't like to have to write your own random number generator function, believe me. Okay, it'd be fairly complicated. So, yeah, it's efficiency in coding time through sharing functions as well. Okay, you see what I mean? That question not so easy. To find the first one, yeah, reasonably. Alex came up with one that was good straight away. But because of the way he phrased it, it was like, you didn't say the word readability. You kind of said, you're going to make the code shorter. by not having to repeat bits of code.
Yeah, you wouldn't have to
So-
repeat bits of code.
So is that readability or efficiency that you're talking about?
Bit of both, really.
Bit of both. Well, I would pick one,
Yeah.
because then, you know, if you say it's more efficient, efficient's a very dangerous word, because a lot of people say it's more efficient. Is it more efficient in terms of time? More efficient in terms of space?
And space.
More efficient in terms of money? Okay, be very careful with that word efficient, because people just use it as a one word fix all.
Yeah.
If I say efficient, I'm covered. If you say efficient, you might have just shot yourself in the foot. Because if you say it's more efficient because I have to write less, you've kind of covered the point that you meant to make and the point that Yehan made in one point.
Yeah.
So you're only going to get one instead of two. If you make them different, so it's efficient in terms of code readability because the code is shorter because I'm not repeating bits of code, and it's efficient in terms of coding time because I can use my own functions again, or I can use pre-built functions. You see what I mean? You've made 1 point into 2 points to enable you to get 3 marks. Let's just show you what's on the examiner's mind.
But you also say
Interestingly,
it said array.
they have put array, but they've put also allow string.
Yay.
Make code easy to read, allow for code reuse / sharing, reduce programmer error, to improve code maintenance, easier to update code. You see those two, you can see where the examiner himself here, or herself, is starting to struggle to come up with more reasons, because those two are kind of the same, aren't they? There's not a huge difference between the two. So, for me, they've been my top 3 answers. Yeah? Try and get yourself a top 3 or top 4 on everything. So that when it comes to the exam, if you see that question, it's like 1, 2, 3, done, move on. It's a really helpful technique. I think it's really important that you remember that question, guys, because it's something that's very likely to come up again. Right, not too bad on this one. Explain with reasons 2 disadvantages of using ring topology in a computer network. So it's told you quite clearly here 2 disadvantages. So there'll be 1 mark for the disadvantage and 1 mark for explaining it. Okay. We knew our stuff here. You know, most people got 3 out of 4 at least. Some people let themselves down because they, for example, didn't explain it. So they said maybe something like. If one computer goes down, the whole ring will go down. Right? Well, I think that's the explanation, isn't it? So what's the disadvantage?
There will be a block in the network.
Instability of the network.
Reliability.
Right.
Yeah, the instability is okay, but I think the word you're looking for is reliability. It's not a reliable network because if one computer goes down, the whole network will go down, so you'll lose productivity. Yeah? Just about just trimming down these answers, refining them a little bit. Yeah. Did Mr. Cowie cover this with you in the internet part?
Which bit? The protocol
So what's an agreed method of communication called?
handshake.
No.
Okay.
People always get those two mixed up.
Yeah, it just sounds like
Yeah.
it should be. What is it? Protocol.
Protocol. A protocol is an agreed set of rules.
Yeah.
So we've got protocols, we agree that, you'll kind of hang around outside until I tell you to come in, and then you'll come in and sit wherever I tell you. If I've told you to sit at this end, you come and you get your stuff out, and while you're getting your stuff out, I get the lesson ready. It's all a protocol. yeah, that we kind of agree to enter into. Handshaking is where you actually start up the communication. So protocol covers anything. So we have a protocol for how we start the lesson, we have a protocol for how we conduct the lesson. If you want to say something, you put your hand up and I choose who I want to speak next. And if I'm speaking, you don't speak. And when we get to sort of 5 minutes before the end of the lesson and you start getting a bit twitchy, you don't start putting your stuff away until I say, you know, and then you put it back in your bags when I've told you to, you push your chairs in, you leave. The protocols cover everything. Handshaking process is just setting up the initial communication. So you could argue that you're following the protocols at first to set up the communication, but that's how they're different. Does that make sense? We get a lot of people mixing the two up. The machine that mostly requests information? Client. Yeah? Software that is accessed over a network such as the internet. Yeah, web application. Programs are sometimes called applications. If you've got one that you're accessing over the internet, it's a web application. I like this question. This one always stimulates a little bit of debate. If you're updating a database, is it being updated on the client, server, or both? The server. The database is on the server. Okay. Validation of user fields.
I would say both. But saying you think it's paid and you didn't get a mark for that, so after that would have probably gone. Is it? And it's got
It's all closed. It's both.
100% both.
Yeah, because the client is running the code that checks, as is the server. Okay, checking username and password. Server. Yeah? Okay, that's not very exciting then. We've not had any debate there.
In this one, you just ticked all the boxes. You should hope they'll give me the mark. That's a pity.
It's juicy. Juicy.
Right, what's a syntax error, fellas? Leo, what's a syntax error?
There's no for.
No. It's not asking you about this code. It's asking you what is a syntax error. It's asking you for the definition of a syntax error. Yank?
A syntax error would be an error in the grammar or the rules of the language.
Absolutely spot on. A syntax error is an error in the grammar or the rules of the language. Okay? We didn't do a great job of answering that question. That should be 100% for everybody. What's the final value of the variable I in figure 1 above? Shouldn't take this long.
I'm trying to think.
Yang?
5.
5. The only time I is changed is in this for loop, and it says for I equals 1 to the length of the array plus 1. The length of the array is 4, so add 1 to it and it's 5. That's where it'll finish. Yeah? Make sure you're not trying to work out array number 5. Why might a runtime error occur on line 4? Why would a runtime error occur on line 4? Yeah, there is no array number 5. It's 1, 2, 3, 4. So array 5 doesn't exist. So you'll get a runtime error because the computer won't know what to do. Why are logical errors the most difficult to find?
Because
The computer doesn't pick them up.
Because you haven't written anything wrong as such. It's just you haven't written what you wanted to do, but what you've written isn't any like syntax error, so you can't pick what you've done.
Just syntax error? Leo?
I think that's because you can only spot the error when you're actually testing it, right? Not before the
Yeah.
problem is there.
So again, you're all giving me an impression you know what you're trying to say, but it's finding a nice way to say it, isn't it? Okay? Logical errors will not be detected by the computer, and the program will run to completion. It just won't do exactly what we want it to do.
Yeah.
So it will run, and it will complete, but the result will be different from what we wanted. Where will there be a logical error, and how will we fix it? So it's supposed to add together all the elements of an array. So where's the logical error?
It's just, it's not really adding to the total, it's just resetting, like
Good. So the error's there.
redeclaring it.
Yeah. So to fix it,
Yeah.
that'll fix it, wouldn't it? Yeah. That's your logical error. It's not going to cause the program to crash. That's what's going on there. Yeah, well done, Phil. Right, as I say, I'm not going to go through that because when we've done them in the past, you've been pretty good at them, and just by looking at the mark scheme, you can get a feel. Normally, the problem with this is people missing bits out. Okay, but you've done flowcharts and pseudocode. The flowcharts and pseudocode that you did were quite good, I have to say, in your controlled assessments. So I'm going to skip that one. I'm going to leave you to it. That's the database one, which wouldn't have been on your exam. It would be useful for you to look at it at some point, but I'm not going to do that one today either. Right. Yeah. This one has come up a fair amount. External code source is a piece of code that's come from somewhere else, not you. It's just come from somewhere else. Okay? So a programmer is developing a website for an online shopping company is using some code from an external source to create the input fields on a form. Give two reasons why the programmer might want to use an external source of code for his website. So why would you use somebody else's code? You've all done it, by the way. You've all used built-in library functions within VB. So why do you do this? Alex?
Save time.
Yeah, I mean, you're going to say more than that on the question, aren't you?
Yeah, obviously, because I saved the programmer time of writing their own code while their code was already out there.
Okay, so it saves you having to write a piece of code that already exists, so it's time efficient. Yeah? What else?
Can also be, well, the positive side. Wait.
This is we're positives, yeah, we're positives.
But this can also apply to the next one on the other side. It can be completely free of bugs and really well built.
Yeah.
So it could potentially be tested. You know, it's probably going to be better tested and hence more free of bugs, depending on where it came from.
Yeah.
But it could be. Yeah. Anything else? Yeah.
It could just help the programmer themselves don't have the
Yeah. He or she or they
yeah.
might be better than you, or they might have a skill that you don't have. So they might have a greater capability in a particular area to code something. Okay, so you've done well on that. What's two potential problems of using an external code source? So what's the disadvantage? You know, where could it go wrong? Alex?
It could cost money to get the code, so you might have to buy the code or buy rights to the code.
Right.
To be able
It could cost money or have copyright
You might
implications.
have to give credit to the coder.
Yeah. Yeah, so you either pay for it or you probably have to sort of give them some credit for your work if you're intending to sell it. Remember, this is to create an online shopping company. So, you know, if you go off and make millions, that person will probably think, I'm entitled to a bit of that. Depends, unless they made it open source. Do you know what open source is?
Anyone can have it.
Hmm?
If they open
Yeah,
code, anyone
unless
can
they've
use
said,
it.
there you go, anybody can have it. Any other problems that could arise?
It could be full of bugs, it could be really well badly coded.
Right, well, you have to make your mind up here, don't you? Because in the first one you've said...
Yeah, well, it could be either. No.
Yeah, okay, you're nearly there. I mean, what's the problem if there are bugs in it?
It
You might not be able to read their program, so you might not be able to.
That's right, you might not be able to edit this.
Yeah.
Because you know that code is compiled and you might just have the sort of executable part of it. So you might not have access to the source code and you might not be able to edit it if there are bugs. And I think, Finn, that stops you from coming up against this problem that you might have said it's probably better tested than I can test it, so it should be free of bugs. And then literally 2 minutes later saying it could be full of bugs. If you say if there are any bugs, they'll be difficult to fix. Or even better, my top answer, it may not do exactly what you want it to do, and you may not be able to edit it. So you might be stuck with something that's not exactly perfect. Okay? You've used App Inventor now, so you should have a good idea of what that feels like. Yeah? That's kind of like using external code. You've got all the advantages and disadvantages right there. Yes, you can turn your brain off a little bit up front because you don't have to code like a heading function yourself. And it's been pretty well tested by MIT. But on the other hand, when it doesn't do exactly what you want it to do, it's a pain in the neck. Okay? And they've kind of made it open source, so there's no cost implications with that. Alright, good. So that's about it for me today, lads. Mr. Cow is going to come in and he's going to give you another AQA paper, and I think he's going to film the lesson as well. Okay, for the people who aren't here today. I hope that was useful.
Yeah.
Yeah? So what we've got to do now is your revision for computer science will consist mainly of doing past papers and going through the mark schemes thoroughly and coming to see me on any bits that you're not sure about. Have you all got the recommended revision guide? The white one, Computer Fundamentals, that you were recommended last year?
No.
That gives kind of a basic blanket summary on everything.
Yeah.
So really nice just to pick, you know, if you've really not done any proper computer science revision, you know, and you just want to pick up a book and refresh yourself on everything, it will refresh you. It does not go into detail though. That's its downfall. So it's, as the first thing you do, it's pretty good. And just to keep dipping into, to check the basics, it's pretty good. But it doesn't go into stuff like this. You know, it's not that detailed. So we have to rely on the past papers and mark schemes for the detail. Okay? Don't forget, I will be here for you. So I'll send out an email later about this lesson on Friday. That'll be your last computer science lesson, except for Monday, which may not be an ideal day to catch you. I don't know. And yeah, from then on it'll be up to you. I'll be here every computer science lesson that you would have had for you to drop in and talk through your own personal queries, which I think is going to be valuable. So Friday, get ready for the gigantic computer science quiz.